Okay, hello Year 10. This is the follow-up to the making salts video. Again, I'm going to try and just do it in one go so I don't have to do too much editing. So bear with me with any mistakes that I make. I'll try not to, obviously. Right, today we're going to be looking at making salts and how to write symbol equations about them. Now this is sort of above level 5, so level 5 upwards. And it's a skill that I would expect all you lot in triple to be able to at least have a really good attempt at. And if you're aiming for 8s and 9s, it's something that you need to get down really well and I'll put a bit of practice into it. So first thing I'm going to remind you is, so salts are ionic compounds. So if you are going to be writing symbol equations, you need to know how to write an ionic formula. And this is something that we did actually practice in class, but quite a long time ago. So ionic compounds are made of positive ions and negative ions joined together. For example, a positive sodium ion and a negative chloride ion. These can join together to make sodium chloride, NaCl. We know that, if you remember at the time, that the rule is that for every positive ion that you have, every positive charge, you need a negative to cancel it out. So because we've got Na+, you only need a Cl- to make the overall compound neutral. Alright, so at the time when we were doing this, I gave you a list of ionic charges and I asked you really to try and memorize them. Now that's not going to be the purpose of today, trying to memorize them, but it is something, like I say, if you're going for a level 9, you need to know the charges. So if I say magnesium ions, I know that magnesium ions are 2+. I've not got my periodic table out, I just know they're 2+ because magnesium is in group 2. And if I have some chloride ions, and somebody asks you what is the formula for magnesium chloride, what I would do is I would say, well, magnesium is 2+, and you're going to check that against the list today to see magnesium is 2+, chloride is 1-, so I would need 2 chlorides to make 2 minuses to cancel out the 2+. So that means that the formula for magnesium chloride is MgCl twice, MgCl2. That is the formula for magnesium chloride. If somebody asked me the formula for aluminium iodide, I would look up aluminium, and aluminium is 3+. The ion aluminium is 3+. Because it's in group 3, let me just remind you, because it's in group 3, that's the atom. So when it bonds, it likes to lose 3 electrons. If it loses 3 electrons, it becomes 3+. All right. Anyway, long story short, aluminium forms 3+ ions. Iodide is in group 7 and it forms 1- ions. So the formula for aluminium iodide, I'm going to need 3 iodides to cancel out the aluminium, and you have Ali3. Okay. So when we're going to be making salts today, if you remember from last time, the names of the salts were chloride, sulfate, and nitrate. So we'll be looking at these in a minute. The sulfate ion is SO4 2-. The 4 is down here, the charge on it is 2-. So if later on we were making sodium sulfate, sodium is an Na+. You know, watching this video now, would you be able to write the formula for sodium sulfate? Sodium forms sodium+, sulfate is SO4 2-. Okay, I'm going to just pause here for about 10 seconds, so I'm going to just sit in silence for 10 seconds while you try and work that out. You can pause the video. I couldn't be bothered sitting for 10 seconds, it felt too weird. Right, so SO4 2-, sulfate ion is 2-, the sodium is a plus, so I'm going to need 2 pluses for these 2 minuses. How do I do? This is not the formula, that's my working out. So the formula is written, well, I've got 2 sodiums, so that's Na and a little 2 to represent 2 sodiums. And then it's SO4, and there was only one of them. So Na twice, SO4 once. That is sodium sulfate. So that's reminding you of this little skill. That is not a full lesson on how to write ionic formula. You can look back in your books to work that out. All right then, so let's make this about making salts then. So following on from last lesson where we're talking about salts are made of a metal part and an acid part. Right, so if I was to say there are 4 ways to make salts, I would expect you to know these 4 general equations. Have a little look at this as a shortcut. There are 4 equations, 4 ways to make a salt. Well, there we go. We're making a salt, so I'll put salt there. Well, we know that each of these ways involves adding an acid, so I could add acid there. I hope this is a nice simple way of learning it. Alright. There will always be another product. Well, you could add the metal to an acid. You could add the metal oxide to an acid. You could add the metal hydroxide to the acid, or you could add the metal carbonate to an acid. So these have all got metals, acids, salts. I remember this one. Metal plus acid makes salt plus hydrogen. Some people call that the Mush Equation. I'll let you work that out. Actually, I don't trust some of you to work that out. Mash. Okay, metal oxide plus acid makes salt plus water. This one is water. This one is water. But the final one, carbonate, like carbonated drinks, you also make carbon dioxide. Alright. I hope that was a useful way of remembering those 4. Quite an easy little bit of memory there. Like a memory test, whatever. Write salt, write acid, fill in the rest. These 3 have got water, whatever. There's loads of ways to learn that. You just need to know that. Okay, the other bit about making salts from last time is if you take something from the metal cupboard and something from the acid cupboard. Right. Well, we know in the metal cupboard we've got metal oxide, metal hydroxide, metal carbonate. Alright, and in the acid cupboard we've got hydrochloric acid, we've got sulfuric acid, we've got nitric acid. Alright, I put phosphoric in last time but I didn't use it, so. Alright, so you've got to know a few formulas. And this is what it comes down to. You need to know some formulas to do this. So, the first formulas you need to know. Hydrochloric acid, you have got to memorize this, is HCl. It's made up of an H plus and a Cl minus, by the way. Sulfuric acid is H2SO4. Because little Timmy had a drink, now Timmy is no more, because what he thought was H2O was H2SO4. And that is made up of 2 H plus ions. That's why it's an acid, if you remember your strong and weak acid homework that I gave you. And it's made of an SO4 2 minus. Nitric acid is HNO3. That's made up of an H plus and an NO3 minus. You have got to learn this, this and this. It is on your specification. The examiner says you need to know the formulas for hydrochloric, sulfuric and nitric acid. Alright. The metals you will get off the periodic table, and you will need to know or need to be aware of the charges on metals. For example, sodium is a group 1 metal, so when sodium is in a compound it forms Na+. If you are a group 2 metal like magnesium, you will form a 2+ ion. If you're a group 3 metal like aluminium, you will form a 3+ ion. Alright. Other little bits you need to know then are let's just have a little look then. I'm just thinking for a sec. I lost my train of thought. Okay, so we know that hydrochloric acid is HCl. We know that hydrochloric acid makes chloride salts. Now the formula for a chloride ion is Cl-. The formula for a sulfate ion is SO4 2-. The formula for a nitrate ion is NO3-. Just check, you can see that little minus up there. Might go over all of these. NO3-. SO4 2 minus and Cl minus. All right. Really, you do need to learn those as well. But you'll see as we go through this, if you know hydrochloric acid, HCl, you can work out that chloride is Cl minus. But anyway, everything I'm doing today, if you want that level 7, 8 or 9 really, you really got to try and crack this and use this time in lockdown to really try and become an expert at this subject. I've taught many people chemistry, and loads of people don't ever learn this and they just about get by. But if you do learn it, your understanding of this topic will just be so much better than people in other schools and, you know, and even your peers in this school. So if you're motivated to learn this, just learn it. Okay. Other things I'm going to show you then, the oxide ion is O2 minus. Now you might be getting a bit confused by now, but try and go with it. Hydroxide ions are OH minus, and carbonates are CO3 2 minus. All right. I recommend now pausing the video and making sure that you have a copy of this in front of you. All right. With hydrochloric acid, sulfuric acid, nitric acid, the formulas of those three acids, the formulas of the ions, chloride, sulfate, and nitrate, the formulas of oxide, hydroxide, and carbonate. All right, I'll pause the video now. Okay, right, so what we're going to do now then is we're going to go back to our little story from the last video, which is, oops, I'll write the R first. Salts are us. All right, and this is where somebody rings up and they ask for a salt. And what we have to do is we have to choose the right acid and the right metal compound to make that salt. All right, so we're going to go with it now. Ring, 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 ring. Okay, somebody is ringing up and they would like you to make magnesium chloride. All right, so they want us to make some magnesium chloride. So what we have to decide then, we try and think about it really clearly and come up with a word equation. Well, if you want to make magnesium chloride, the name of the salt, the target salt is magnesium chloride. There's a few ways to make that, but they all require an acid. So if I want to make a chloride salt, I hope you realize that I'm going to use hydrochloric acid. And I can make this salt in a number of ways. I can put metal plus acid makes salt plus hydrogen. I could have metal oxide plus acid makes salt plus water, or I could use a carbonate. Well, I'm going to go with, which one? Let's just go with metal. I'm going to do the one way, MASH. Metal plus hydrogen, metal plus acid makes salt plus hydrogen. So I could take magnesium plus acid makes magnesium chloride plus hydrogen. So I start off by coming up with the word equation. I don't dive straight into symbols. To do the symbol equation for this, all you need to do now is, where there's a word, come up with the symbol for it. So underneath this word equation, I am now going to write magnesium, I know is Mg on its own. Hydrochloric acid, I've just learnt this, is HCl. Magnesium chloride, I'm not sure about, but hydrogen, I know is H2. So what you've got to do, you have to pause and you have to think, what's the formula of magnesium chloride? You don't need to work out the others because you've learnt them. This one's off the periodic table. This one you've learnt. This one you should know. I've just got to work out magnesium chloride. So up here I'm going to do the working out. Magnesium is Mg2+ because it's in group 2. Chloride is Cl- because, well, I've learnt it, and also because it's in group 7. So I'm going to need 2 Cl's for the magnesium. This is me thinking, I think this is MgCl2. All right, that is me coming up with a formula for magnesium chloride. Now, that would be worth 2 marks in the exam as it stands. 2 marks, but there is a 3rd mark to get. Oops, I have ticked it over there, but it's gone off the screen. And can anyone tell me what the 3rd mark? Can anyone tell me? If you're thinking now, what's wrong with this equation? All right. once you've got the formulas in the right place, and if you have the formulas correct, you always need to check to see if it's balanced. All right, and we do that by looking at each element individually. So magnesiums, I've got one magnesium on this side and one magnesium on this side. That's okay. On this side I've got one hydrogen, but on this side I've got two hydrogens. On this side I've got one chlorine, called chloride. On this side I've got two. Right, so a large number, we balance by putting large numbers in front of things. You can't put small numbers in these formulae because that would change the compound. All you're allowed to do is put a large number here, and the large number fix here is quite simply a 2 in front of that. All right, one magnesium, one magnesium. 2 HCl's would mean I have 2 H's and 2 Cl's. Okay, that's done, and that's your third mark. All right, I'm going to go through a selection of about 4, and then I'm going to set you some questions. All right? So, I mean, this is tough. I don't need you to be doing this from memory. You can be using this sheet. You can be using your ions sheet that should still be in your books if you've got your book at home. You could look up formulae of common ions, GCSE. If you Google that, you will find the formula of the ions, which means you can write the compounds, whatever. Okay, so ring, 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 ring. Somebody wants you to make some sodium sulfate. All right. So first thing I'm going to do is I'm going to write an equation, a word equation, sodium sulfate. So that's sulfuric acid. They want me to make sodium sulfate, so I'm going to write sodium sulfate there as a product. How am I going to make this? Well, it's going to be sodium something. It's probably not a good idea to put sodium into sulfuric acid, so I might use sodium oxide or hydroxide or carbonate. Any of those will do, but I'm going to use oxide here. If I'm using oxide plus acid, that means I'm going to make water. All right, that's hard. That's hard enough. That was last video. That's worth a couple of marks in the exam for knowing how to make sodium sulfate, for choosing the right acid and the right, making the right products as well. Okay, symbol equation. Well, first thing with a symbol equation is write down the symbols that you know. I know water. Everybody knows water, so write H2O. Sulfuric acid, little Timmy had a drink, etc., etc., H2SO4. And now I'm left with sodium oxide and sodium sulfate. Now, I do know the formulas for these, but I don't think you will at this stage in your life. All right, so you're going to have to work them out. Okay, sodium sulfate. Sodium ions are Na+, sulfate ions is SO4 2-. I'm telling you, it's about time you need to start learning them, okay? By the end of this video, you'll be more familiar. So what's the formula of sodium sulfate? Well, I'm going to need 2 sodiums for every 1 sulfate. So that is Na2SO4. Nearly finished. Sodium oxide. Do you know the formula for sodium oxide? You're going to have to work it out. Sodium is Na+, and oxide is O2-. You can look those up. I'm letting you look those up, okay? So I'm going to need 2 Na pluses for 1 O2-. At Na2O. Let's get rid of that, it's in the way. There's my working out done. Finally, so I'm happy with the formulas, the individual formulas. That's a formula, that's a formula, that's a formula, that's a formula. And now I need to balance the overall equation. Right, 2 sodiums, Na twice, that's fine. 1 oxygen on its own, tricky to work that out. 2 H's, H2, 2 H's, H2. An SO4, an SO4, an O, an O. Right, 1, 2, 3 marks in an exam. You're going to get a level 9, mate. All right. So, the word equation we did last time. The symbol equation, get as many symbols that are easy to get, and then work out the ones that you don't know. Okay, let's carry on with that idea then. I'm going to turn the sheet this way. Somebody rings up and they want some aluminium. Oh, I can't bother with aluminium. Calcium nitrate. All right, they want calcium nitrate. And they want you to make it, I don't know why, but they want you to make it from a carbonate. You know. So isn't that interesting? They're demanding that you make it from a carbonate. So, what am I doing here? I'm meant to write calcium. So the salt I'm making is calcium nitrate. You choose the acid. Nitric acid, good. I'm going to make water. and I'm going to make carbon dioxide. Remember from last time, if I've been asked for a word equation, you are not allowed to write CO2 and H2O. A word equation is using words. All right, calcium nitrate. I've chosen the nitric acid. Now I need to use calcium something. I could just use calcium on its own. I could use calcium oxide. But I'm making carbon dioxide, so I need to use carbonate. Okay, there's the word equation. Boom, boom. It's marked in the exam. Well done. That is a hard skill. All right, symbol equation. First job, put in the symbols that you know. H2O, CO2. I expect you to know CO2. Nitric acid, I told you I need you to know this one, HNO3. Which leaves us with calcium nitrate and calcium carbonate to work out. All right, so you have to stop in the exam and work them out. Calcium is Ca2+, because it's in group 2. Nitrate is one that you have to learn, NO3-. All right? It's not NO3-, it's NO3 with a single minus charge. That means I need 2 NO3 minuses to cancel out the 2 pluses. That means calcium nitrate is Ca and NO3 twice. That looks a bit funny, doesn't it? Because that says NO32, which is why we need some brackets around the NO3. All right. I go to the other side, calcium carbonate. Calcium is Ca2+, and carbonate, I'm going to give you this, I gave you it on your table, is CO3 2-. If you notice here, you've got a calcium 2+ and a CO3 2-. They cancel each other out anyway, so you're left with CaCO3. All right, you've got all your formulas right, you're doing really well, you've got 2 marks out of 3. To get this 3rd mark, it just needs to be balanced. Simplest place for me to look, can you see that I've got NO3 twice over here and I've only got NO3 once over here? I'm going to stick a big 2 in front of there. That balances it, by the way. Alright, 1 calcium, 1 calcium. A carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9 oxygens. 1, 2, 3, 4, 5, 6, 7, 8, 9 oxygens. It's balanced. Alright. So, alright, just need to carry on this video. That was my mum just rang me on Skype and it cut off the video. So, I'm going to carry this on. I was going to say, we've done one with a metal oxide and one with a metal carbonate. We're going to make a salt now using a metal hydroxide. Okay, so somebody rings up and they want you to make some copper. What should we make? Copper sulfate. Copper sulfate, very common salt to make in schools. Right, copper sulfate. Word equation. Copper sulfate. Right, acid is sulfuric. You're seeing how I've got a system going on. I put the acid there. How can I make copper sulfate? Well, I'm going to use copper. I couldn't use copper because it's too unreactive. I could use copper oxide. I could use copper hydroxide. I could use copper carbonate. I'm going to go for copper hydroxide because I've not done a hydroxide one yet. And that means I'm going to make some water as well. There's the word equation. Piece of cake. All right. So now I'm going to do the symbol equation. Sulfuric acid, little Timmy had a drink, H2SO4. Water is H2O. I'm getting some easy marks here. Copper sulfate. Now, you need to know the charge on a copper ion or it will be given to you. You can't really work it out from the periodic table because it's a transition metal. It's not like in group 1 or group 2. So it forms 2+ ions. Sulfate is SO4 2-. Cu2+, SO4 2-. So there's a 2+ and a 2-, so the formula is CuSO4. Copper hydroxide, copper is Cu2+, as we've just discussed, and hydroxide is OH-. So there's 2 pluses and 1-, so I'm going to need 2 OH-. CuOH2, that doesn't quite look right. It's CuOH twice. All right, now I need to balance it. 1 copper, 1 copper. 1 SO4, 1 SO4. Okay. 1, 2 hydrogens and 2 oxygens. Hang on a minute. This is going to be a little bit trickier to balance because I've got too many hydrogens. 1, 2, 3, 4. 1, 2, 3, 4. I've got 2 oxygens on this side, so I need to get balance in. This ain't gonna work. Gosh, this is a bit of a pain to balance. That looks balanced, but it's not. It makes too many oxygens. I wish I hadn't have chosen this as an example. I'm going to pause the video and work it out. Right, let's pretend that didn't happen and I didn't get stuck. I've worked it out actually. That's it's a tricky one, this, to be honest. I'm going to put a 2 there, 2 CuSO4s. That means I've got 2 coppers, so I'm going to put that there. I've also got 2 SO4s, which means I'm going to have to put a 2 there. And now I can just balance out the waters. If I count up the hydrogens on this side, I've got 1, 2, 3, 4 hydrogens. 1, 2, 3, 4 hydrogens. I've got 8 hydrogens over this side. So 4 H2O. I think that balances. I'm seriously. This is a hard one. So let's see how you get on. Right. I got the formulas right, so I'm happy with that. I just need to check. 2 coppers. 2 coppers. There's 2 lots of CuOH2. So there's 1, 2, 3, 2 oxygens. I'm going to count the hydrogens. 1, 2 hydrogens times 2 is 4 hydrogens. And then there's 2 times 2, there's 4 hydrogens there. There's 8 hydrogens over there. So hydrogens balance. 2 oxygens times 2 is 4 oxygens. There's 4 oxygens there. And there's 2 SO4s. Yeah, that balances. All right, I wasn't joking there. That was a little bit tricky. I thought it was going to be really easy to balance, but it wasn't. Right, so the plan is, when you're doing these, is 1, have the ion charges to hand, somewhere nearby. Have the ion charges to hand. To start off, have a list of ion charges. So here are the typical ones: hydroxide, OH minus, oxide, O2 minus, carbonate, CO3 2 minus, chloride, sulfate, nitrate. Chloride, sulfate, nitrate. Positive ions that you will need will be group 1 metals, Na+, group 2 metals, Mg2+, so that could be Na+, Li+, potassium+, Mg2+, calcium 2+, etc. Group 3, aluminium 3+. And I think that those charges there will probably get you most of the way there. All right, I'm going to throw in a copper 2+ in there as well. You could do with learning that. All right, have the ion charges to hand. Number 2, write the word equation. Number 3, fill in the easy formulae. You know, the HCl, the H2O, the CO2, the H2SO4, etc. Number 4 is work out ionic formulae of the salts, etc. And number 5, balance. Each of these steps gets you marks in the exam. So if you're struggling on number 5 at home, don't start crying and saying, I can't do it. If you've done all of this, you're doing really, really well. If you're just getting stuck on balancing, well, you know what? We'll be in school all next year. We can sort out your balancing of equations. Work on your word equations. Work on your ionic formula. Do something that's good. So don't, as I say, don't throw the baby out with the bathwater. Don't go, don't overthink it. If you're getting stuck on number 5, don't worry about it too much. If you're getting stuck on writing word equations, you need to go back to the other video. All right? If you're getting stuck on writing H2O and CO2, you need to get a grip. if you're stuck on working out ionic formula, you need to look back in your book to some of those earlier lessons that we did and practice that. That's a worthwhile thing to practice. If you're getting stuck on balancing, well, you know, practice. And if you can't do the balancing, again, don't cry about it too much. You know, you're doing really, really well. Okay then. So now what I'm going to do is I'm going to set you some challenges. All right. And these are as follows. Ooh, I've run out of paper. Gosh, I do write a lot, don't I? Okay. I would like you to make calcium nitrate. I would like you to make lithium sulfate. I would like you to make sodium chloride. And I would finally might like you to make magnesium. I'll choose one of these. Sulfate. Okay. I would like a word and a symbol equation for each of these. And so one word and one symbol equation. 1 times word, 1 times symbol. And I would like you to use 4 different methods. So make one of these using metal plus acid makes salt plus hydrogen. Make another one using the metal oxide plus acid. Make another one using the metal hydroxide. And another one using the metal carbonate. Alright? So you might choose to make lithium sulfate by choosing lithium oxide plus sulfuric acid. You might decide to make magnesium sulfate by just using the pure metal and the acid. I hope that makes sense. So that's your task. In an exam, that will be worth tons of marks. Tons and tons. So this video is about 30 odd minutes long that you had to sit through and practice along with. And then this little task as well will take you a little bit of time. Will take you another sort of 20 minutes. So I think that's about right for the amount of work for this week. I hope that's okay. I'm sorry this is only getting to you on a Tuesday. But yeah, I think it's an important lesson, and I'm hoping that it'll sort of demystify writing equations a little bit. I hope it doesn't stress you out too much. All right. Hope you're all really, really well. Thank you for asking if me and my family are well. We are. And yes. So good luck with this. And let me know how you get on. Thank you.